Okay, now we take the calculation of charge density, bond order and structure of benzene. So first we take that charge density. As earlier I have told you that for calculating charge density there is one formula, that QR is equal to summation J NJ CJR square, where QR is the contribution of atomic orbital on rth carbon atom to jth molecular orbital, Nj is number of electrons, and C square Jr is contribution of jth contribution of rth atomic orbital to jth molecular orbital. So we know that we have already 6 pi electrons, and we take one by one. So first we take that Q1, we calculate Q1. Q1, this J summation goes on molecular orbital. So we write down molecular orbitals. These phi 1 is equal to 1 by root 6 F1 plus F2 plus F3 plus F4 plus F5 plus F6, and phi 2 is equal to 1 by 2. This is no contribution, C1 was F2 plus F3 minus F5 and minus F6, and phi 3 is 1 by root 3, and this is F1 plus half F2, and this is minus half F3 minus half F minus F4 and minus half F5 plus half F6. Thank God that charge calculation is in square. So Q1 is that first we take that contribution to first atomic orbital of first carbon atom. So this is, we are taking first carbon atom, so we fix J barabar first molecular orbital. So and Nj is number of electrons, where Nj is number of electrons. Nj is equal to number of electrons. Number of electrons. So Nj is number of electrons. So we first calculate on that distribution of charge on carbon atom number 1. So Nj is number of electrons 2, contribution of first orbital to this first carbon atomic orbital is 1 by root 6 whole square plus. Now summation goes on molecular orbital. Now contribution of first atomic orbital to this molecular orbital is 0, because there is no F1, no C1, and for third, due to this carbon atom number 1 to this molecular orbital, this is 1 by root 3 whole square or 2 multiplied by 2. So we get 2 into 1 by 6 plus 2 into 1 by 3. So we get 2 1 by 3 plus 2 by 3. So we get this is 1. Now we take Q2 charge density on Q2. So now we take second carbon atom F2. So again first orbital J is equal to, we fix J barabar 1, then it is 2 number of electrons 1 by root 6 whole square. F2, this is 1 by 2, again number of electrons 1 by 2 whole square, and F3 is 1 by 2 into 1 by root 3 whole square. So we get 2 into 1 by 6, 2 plus 2 into 1 by 4 plus 2 into 1 by 3. So we get 1 by 3 2 1 by 2 2 into 1 by 3. Sorry, this is for Q2. Q2 is 2 into 1 by 2 into 1 by root 3 whole square. So 1 by 3 plus 1 by 2, and this will be 2 into 4 into 3, this will be 1 by 12. So we get 1 by 3 plus 1 by 2 plus 1 by 6 is equal to this again 6 2. So this is 6 by 6 is again charge on Q2 is equal to 1. And now Q3, this is Q3, sorry, this is Q3. That first is first orbital 2 electrons and contribution to this of this carbon atom 2 into 1 by 6 because it is Cr square. Contribution is Cjr square, that is rth carbon atom, and this is gth molecular orbital. So 2 1 by root 6 plus this is minus 3 plus, and this is third and this is third, then so we by mistaking it was I spoke to, but it is the charge on third carbon atom. So we have already explained Q1 and Q2, and now I explained Q3. We will further see that all charges are equal. It shows that the charge is equally distributed among all the carbon atoms. From this Q, now we take for Q4. Q4 is equal to that we fix for J barabar phi 1, and F1 contribution is for 2 electron 2 root 1 by 6 square. Here F4 is missing, and 2 into root 1 by 3 1 by root 3 whole square, because F4 is 1 by root 3. So we get Q4 is equal to 2 into 1 by 6 plus 2 into 1 by 3, or 1 by 3 plus 2 by 3 is equal to 1. So charge in Q4 again it is 1. Now Q5, now we take for Q5, this is equal to J, that is for 2, 1 5 is 1 by root 6 whole square plus minus 5 1 by 2, so this minus 1 by 2 whole square plus 2 into minus 1 by 2 whole square plus this 5 F5 2 into 1 by 2 minus into 1 by root 3 whole square. Therefore, we get 2 into 1 by 6 plus 2 into 1 by 4 plus 2 into 2 4 and 3 1 by 12. Therefore, we get 2 3 is 6, 4 and 2 6. So, we get 1 by 3 plus 1 by 2, 1 by 2 plus 1 by 6. So, we get again it is equal to 1. 6, 3, 2 plus 3 plus 1. Now Q6. Now we calculate for Q6, that Q6 is again for first molecular orbital 2 by 1 whole square minus that plus minus 1 by 2 whole square into 2, because all these molecular orbitals are having 2 electrons, so we are calculating charge density for only these 3 molecular orbitals and not for anti-bonding orbitals. We will calculate for charge density only for bonding molecular orbitals. Then plus 2 into 1 by 2 into 1 by root 3 whole square. So, it is 2 into 1 by 6 plus 2 into 1 by 4 plus 2 into 1 by 12. Therefore, 2 3 2 and this is 2 6. So, we get 1 by 3 plus 1 by 2 plus 1 by 6 is equal to 1. So, this is all about charge density. Today we calculate the pi bond order for benzene, and here are some points to be noted. So, please go through these points, and I will explain these points when I calculate the bond order. So, simply you just go through, and here I am writing, here only I have written only 4 points, and now I just rub and I will write the 5th point. Now we calculate pi bond order. So, we write down heading that calculation of pi bond order in benzene for benzene कर दे रहे हैं, for benzene, pi calculation of pi bond order for benzene. As earlier you have gone through that for calculating pi bond order, that is p pi, yeah, that is pi bond order PRS is defined as summation j and j Cj r Cjs. So this is that pi bond order which is represented PRS, where R and S are directly bonded carbon atoms or adjacent carbon atoms which are bonded, and J is molecular orbital, Nj is number of electrons in molecular orbitals, Cjr, this coefficient of rth atomic orbital to jth molecular orbital, and this Cjs coefficient of sth atomic orbital to jth molecular orbital. So definitely, as we know that benzene has 6 carbon atoms, so this will be 1, 2, 3, 4, 5, 6. So I will just expand it, that PRS is, suppose this is first molecular orbital N1 and R is 1, 2, that is bond order between 1 and 2. So I am writing for whole bond order, N1 for first molecular orbital, and this is suppose it is P12, then how we will write? P12 N1, C for first orbital from first carbon atom multiplied by C1 from second atomic orbital plus N2, this is second molecular orbital. So this is second molecular orbital, and this will be multiplied by coefficient of first N2, first carbon atom, second carbon atom, N2, C2 1 into C2 2, and plus N3 C3 1 C3 2 plus C4 1, this is N3 plus N4 C4 1 C4 2 plus N5 C5 1 C5 2 plus N6 C6 1 and C6 2. So this will be the pi bond order between first and second carbon atom to all the 5 orbitals. But we know that our we have 3 anti-bonding orbitals and 3 bonding orbitals, and only these bonding orbitals are occupied by 6 electrons. So this will be 0. This is anti-bonding orbitals and it is equal to 0. So we will not entertain these molecular orbitals. So I have rubbed this. So now we are calculating the bond order, and that is P12. It is between first and second carbon atom. So I should write all these 5 molecular orbitals. Just suppose this phi 1 is equal to 1 by root 6 F1 plus F2 plus F3 plus F4 plus F5 plus F6. Similarly, phi 2 is 1 by 2. Here C1 was 0, so F2, just I will see 1 by 2 F2 plus F3 minus F5 minus F6, and phi 3 is equal to 1 by root 3 F1 plus F2 minus plus half F2 plus half F2 minus half F3 minus F4 minus F4 minus, this is F4 minus half F5 and plus half F6. This we will calculate pi bond order. So this is 1, 2. So N1, how many electrons are there? 2 electrons are there. 2, N1 is 2. C11, C11, first molecular orbital 1 and 2, and 1 by root 6, 1 by root 6. 2, 1 by root 6 whole square. Now next N2. N2 is having 2 electrons, C21, the second molecular orbital, and first contribution of first atomic orbital. Here it is 0, so we will write down 0. No F. Third, now F1, F2. So electrons are 2. F1 is 1 by root 3 and F2 is 1 by root 3 multiplied by 1 by 2 root 3. So this is 2 into 1 by 6 plus 0 plus 2 cancel. So we get this 1 by 3 plus 1 by 3. So you get 2 by 3, 2 by 3, 2, 1 by 3, no, this is wrong. 1 by 3 into 1 by 3, that is 1 by 3, and 2 is cancelled, so 1 by 3, and this is 2, 1 by 6, and phi 2 is 1, 2. 1 is missing, so this will be 0, 2, this whole will be 0, plus 2 into 1 by root 3 F1 and 1 by 2 and 1 by root 3. So 1 by root 3, 1 by root 3 is 1 by 3, 2 by 6. Just calculate. So this is 1 by 3. 3, 3, 1 plus 1, this is 2 by 3. That is approximate 0.66. So this is the bond order between 0.66. This is first molecular, or this is the bond order between first and second carbon atoms of all the 3 molecular orbitals, and that is 0.66. Now we calculate, this is, now we will calculate for 2, 3. So this will be n1, and second, this is n1, second, first 3 and first 2 and 1 3, 2, this is 2 2 and 2 3, and this is 3 3 2 and 3 3. This will be like this. So we calculate n1 2 electrons, 1 by root 6 into 1 by root 6 plus n2 2 electrons, C22. C22 means 2 electrons into 1 by 2 and into 1 by 2 plus n3 2 electrons, and 3 is 2 is 1 half F2 and minus. So we will get half, that is 1 by 2 root 3 and minus 1 by 2 root 3. So we will get here from here 1 by 3, 2 by 6 plus 1 by 2, and this is 2 is cancelled, so we get minus, it will be minus 1 by 6. So this can be again 6, 2 plus 3 minus 1. This is again 4 by 6, and this is 2 by 3, so it is again 0.66. This is a bond order between 2 and 3. And now we take 3, 2, 3, 3, 4, n1 n1 C13 C14 plus n2 C23 C24 plus n3 C34. Then n1 electrons to C13 1 by root 6 whole square plus n2 2 C23 C23, that is F3, that is 2 into 1 by 2, and F4 is missing, so 0 plus n3 again 2 C33 yani minus half 2, and 4 is full, C that is one coefficient C1. So we write 2 electrons multiplied by minus half into 1 by root 3, and that is 4. So I write 1 by root 3 of minus. This is for minus. So it is 2 by 6. Yeah, this is 1 by 3 and plus 0 plus 2 is cancelled, 2 is, so we get 1 by 3 minus plus 1 by 3, again it is 2 by 3 and it is 0.66. Now we take P4 5, then N1 C4 C5, N2 C4 C5, where the number you just write down 4 5s, N2 C4 5, N3 C4 and C5, N1 again number of electrons to C4 is and C5 is 1 by root 6 whole square plus N2 C4. C4 is missing, so 0 plus N3 2 electron C4, that is minus 1 by 3 into minus 1 by 3 and minus 1 by 2 into 1 by root 3. So here we get 1 by 3 plus 0 plus 2. So we get minus minus plus, this is 1 by 3 and again it is 2 by 3, that is 0.66. And now last 4 5 last but one, P5 6 and it is C5 C6 C5 C6 and this is C5 and C6. This will be same, plus N2 2 electrons C5. C5 is minus 1 by 2 and C6 is again minus 1 by 2 plus 2 electrons. C5 is minus 1 by 2 into 1 by root 3 into 1 by 2 and into 1 by root 3. This is of plus. So here we get 1 by 3 plus this is 2 minus minus plus 1 by 2 and plus 2 is cancelled and this is minus, so it will be minus this 1 by 2 into 3 minus 1 by 6. So it will be, just see, 3 2 6, that will be 3 2 plus 2 3 plus 1, that is 5 by 6. 2 plus 3 plus 1, that is minus, sorry. This is minus. So we get 4 by 6 is equal to 2 by 3, that is 0. This is 0.66. And now last is the 6-1. Benzene is having the bonding between first and sixth carbon atom, 6-1. N6 C6 C1 N2 C6 C1 N3 C6 and C1. N1 this will be 6-1 है ना, therefore this will be N1 and C16 and C11 and 2 जो है, therefore C26 and C21 C36 and C and 2 C26 and 3 C36 and C31. This is the coefficient. So N1 16 N1 2 1 by root 6 whole square plus 2, 2 6. 2 6 is minus 1 by 2. Minus 1 by 2 and 2 1. That is 2 1 is missing. Yes. 2 1 is 0 plus and 3 2 and C 3 6. C 3 6 is 1 by 2 and this 1 by root 3. 1 by 2 root 3, this will be 1 by 2 root 3 into 1 by F1 is 1 by root 3. So it will be 2 into 1 by 6 plus 0 plus 2, this is 1 by 3 and this is 1 by 3. Then 1 by 3 plus 1 by 3 is equal to 2 by 3 is equal to 0. So this we have calculated bond order for all the bondings between 6 carbon atom. Now we calculate bond order finally, that is p pi bond order. Bond order is 0.66, represent that, and this pi bond order comes that P12 बराबर is equal to P23 equal to P34 equal to P45 equal to P56 equal to P61, and this is all equal to 0.66. Then definition of pi bond order. This is for benzene. 0.66 is for benzene. And if we use Huckel formula for calculation of pi bond, this is 1 by 2 number of electrons in bonding orbitals minus number of electrons in antibonding electrons in antibonding orbitals. So here if we calculate, then it is 1 by 2 number of electrons in bonding orbitals is 6, that is into number 0, so it is 3. And pi bond order per carbon atom, pi bond order per carbon atom is 3/6 is equal to 1/2 is. Then we expected that its value should be 0.5, but actually we calculate bond order, it is 0.66. It means this bond order is greater in benzene than other aromatic hydrocarbons. Difference is that is 2 by 3. Difference is, so this actually this higher value 0.166 actually comes from aromatic stabilization, and earlier I have already explained that 2 beta for pi electrons causes that that benzene pi electrons are more stable than the collection of 3 double bond. So this extra value gives more stability to benzene, and this is all about bond order. Okay, today we explain the representation of molecular orbitals. Earlier I told you that contribution or square of contribution, square of coefficient, actually this is the contribution of electronic density to that particular atomic orbital. And so we can say that in the expression of molecular orbital, the square of coefficients of atomic orbital represents the contribution of electronic density. Second is the since electron represents the wave, or electron is a wave like this, electron is a wave, and we represent wave as this is plus, as this is minus. So in a similar way, that lobes of the orbitals is this. On upper side will be positive lobe, and lower side will be negative lobe. So this is the second point. So since electron is a wave, therefore atomic orbital can be represented by positive lobe and negative lobe. And third is, if these lobes are in phase, if these lobes are in phase, suppose these lobes are in phase, positive, positive, negative, negative, positive, positive, negative, negative, positive, positive, and negative, negative. Suppose when these lobes are in phase, they give constructive interference, and when they are in opposite phase, like this, when they are in opposite phase, so they give the destructive interference. And when they are in the phase, definitely the bonding molecular orbitals are there, and when they are in opposite phase, then anti-bonding orbitals are there. This is the fourth point. And if two lobes at the adjacent carbon are opposite sign, suppose these are adjacent carbon atoms and they are of opposite signs, so they will cancel the effect of each other. And if there is phase change, last point is, if there is phase change like this, phase change is here is no phase change, here is phase change. So whenever there is phase change, then between adjacent carbon there will be a node. Whenever there is a phase change between two adjacent carbon atoms, then there will be a nodal plane. So just taking these points, we can represent it that this is 6 carbon atoms, and all the carbon atoms are distributed equally. These plus 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 and minus 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 minus. This benzene is a planar molecule like this, and positive lobes are on the upper side, and negative lobes are on the lower side, and this is a planar molecule. So here we see that lobes, positive lobes are on the upper side forming ring, and 6 negative lobes are under this planar molecule. So and lobes are also of equal size, and it means that charge is equally distributed for this, for first. Now if we come for second, we see that this is positive and positive on upper side, planar molecule on upper side it is positive lobes, and in the lower side again positive lobes are there. So these also form bonding, and here no contribution of atomic orbitals. So this shows a nodal plane, because there is no contribution of 1 and 4. So this is showing a nodal plane. Now we come for third BMO. So here you see that first positive lobe, second positive lobe, and third positive lobe. So these again create bonding molecular orbital, and all the 3 negative lobes are on the lower side. So also so these molecular orbitals contribute for bonding molecular orbitals, because if they are in phase, I have already told that if they are in phase they will constructive interference, or we can say that bonding molecular orbital. So here they are in phase, and all these 3 are in phase, and these are also phase. So again we get bonding molecular orbital. Now we see for anti-bonding molecular orbital. Here you see that there is plus, it is negative, this is negative and this is positive, cancel, and this is positive and negative on the upper side, cancelling each other. Similarly, negative, positive, negative and positive, so cancelling each other. So they will definitely not make bonding orbital, otherwise they anti-bonding molecular orbital. Because this positive is cancelling this cancelled by each other, so they will form anti-bonding molecular orbital. Now see, these are 2 adjacent carbon atoms, and they are in opposite phase. So here we can say that phase change is taking place, like this, plus minus, and when this is going to plus minus, so this is the phase change point. So here also in the middle there is phase change point. This is nodal plane, this is again nodal plane, and we see that here is also phase is changing. This is plus L, this is negative. So here in the middle it will also have plane. So we will just join these 2 planes, and we get a nodal plane here again, and here this is nodal plane, because there is no contribution of 1 and 4 atomic orbitals. And this is 4th molecular orbital. See, positive, negative, positive, negative, positive and negative. It means they will cancel each other, or it will result in anti-bonding molecular orbital. Similarly, see, negative, positive, negative, positive and negative, positive, so we will cancel each other. So results in formation of anti-bonding orbital. Now see, this is phase change like this. Here it is negative, it is plus, phase change. So in between again phase change, again phase change, again phase change. So these 2 nodal planes will go in between. So we get these 2 nodal planes, and this is again plus, negative and positive and negative. So here from where we get nodal plane. So how we get this molecular orbitals for this molecular orbital representation, and in this charge is when this orbitals are formed, then bonding orbitals, then we see that charge is distributed among all the 6 carbon atoms. This how we got these molecular orbitals, that it is positive, so it is positive, all the 6 carbon atoms are positive, so positive orbitals are in upper dimension. Here that first is absent, so there is no orbital. Second is F3, so positive. F5 is negative, so F5 is negative. 4 is absent, and 3 is positive, so here we have made 3 positive, and this F6 is negative, so here we have made low on the lower side. And in the similar way we can see that suppose I take phi 3 and F4 is negative, so this is phi 3 and F4 is negative, but the positive sign is below the planar molecule, it means. So we can explain all these by in the representation of molecular orbital. Thank you.